Hello students, in this video I am going to explain what is performance analysis and what is space complexity, how to calculate space complexity for an algorithm. In the last video I covered what is pseudocode and how to write an algorithm using pseudocode. If anyone want to see that video, I'll provide the link in the description box. You can able to check that. Now we will see what is performance analysis. An algorithm is said to be an efficient and fast if it takes less amount of time to execute and consumes less memory space. So when we will say an algorithm is the best algorithm, nothing but if the algorithm takes minimum amount of time for its execution and less amount of space for its execution, that algorithm we will be considering it as the best algorithm. Not only space and time, there are so many metrics like bandwidth, registers, battery power. Based on the time, space, bandwidth, registers and battery power, we will select one best algorithm. But among these, mainly we focus on space and time complexity. These two are main metrics. So the algorithm performance can be analyzed by using two techniques, that is space complexity and time complexity. So in this video, we will see what is space complexity and how to calculate space complexity for an algorithm. So space complexity nothing but the amount of space required by an algorithm for its execution, nothing but space complexity. How much space required for algorithm to its execution, nothing but space complexity. Generally the space required for instruction space, data space and environmental stack space. Instruction space nothing but once you write the algorithm, whatever the instructions you are having, to store that instructions you require space, right? So all that instructions will be stored in instruction space. If you are having any variables or constants, that variables will be stored in data space. All instructions will be stored in instruction space and all variables and constants will be stored in data space. Environmental stack space nothing but to store environmental information needed to resume the suspended function. Suspended functions nothing but mainly this space is used for recursive function. If your algorithm having any recursive function, to store all recursive function calls details, you require stack space. You no need to worry about this. In the next video, I will cover what is the environmental stack space. Instruction space nothing but required to store the compiled version of instructions, and data space nothing but required to store the constants and variable values. Environmental stack space nothing but required to store the environmental information needed to resume the suspended functions. So how to calculate space complexity for an algorithm? The formula is S of P is equal to C plus SP. So SP nothing but instance characteristics. Characteristics nothing but input, output, load. So all these are instance characteristics. Input, output, load, read, all these comes under instance characteristics. So S of P is equal to C plus SP. S of P nothing but the space complexity of a problem or algorithm or program. S of P nothing but the total amount of space required by an algorithm, nothing but S of P. So here C is what? Constant part. So it is independent of the input and output. So SP nothing but this is the variable part or dynamic part. So it is depending on the input and output. Let us see how to calculate space complexity for this algorithm. So this algorithm represents sum of three numbers. So algorithm, this is the algorithm name and it has three parameters x, y, z, and it is returning x plus y plus z. It is returning the summation of all the values of x, y and z. Okay. So if you want to calculate for any algorithm, to calculate the space complexity, first step is you have to note down all the variables of your algorithm. To calculate the space complexity, first you have to note down all the variables of your algorithm. So what are the variables you are having in this algorithm? X is one variable and Y is one variable and Z is one variable. So here we don't know what is the data type of this variable. Just we are taking the variables. But when you apply this algorithm as programmatically, user may take that x value as integer or x value as float data type or x value as double data type. Okay, we don't know what is the exact bytes required by that variable, right? So generally, to calculate the space complexity for each and every variable, we are taking it as a one word. One word, nothing but it may be a 2 bytes or it may be 4 bytes or it may 8 bytes. We don't know, because for compiler to compiler and language to language, the data type size will be different, right? So here we are taking generally one word, and Y takes one word space and Z requires one word space. Okay, here X having their own value, Y having their own value, Z having their own value, right? So these variables are not depending on any other variable. So that here we have taken each and every variable has required, each and every variable required one word space. Y required one word space and Z required one word space. Okay, so these three are what actually constants. Constant nothing but what? If the variable is not depending on any other variable, that is the constant. So what is the formula here? S of P is equal to C plus SP. Here we don't have any independent variable. So we are having only constant. So you have to add all the constants. So that is 1 plus 1 plus 1. That is 3. 3 words. What is the total space required for this algorithm? 3 words. Right? Next example, this algorithm represents addition of all array elements, sum of array elements. So here A is the array name and M is the size of the array. So initially the S value is 0. So next for I is equal 0 to M minus 1, do S is equal to S plus A of I. So we are adding all array elements by index by index. First it will add 0 index element. Next I value will be incremented by 1. Next it will add 1 index element. Next it will add 2 index element, like that based on the array size. So we will see. So how to calculate space complexity of this algorithm. Okay. So what is the first step? You have to note down all the variables of this algorithm. So the variables we are having in this algorithm, A is one variable, right? Next, M is one variable. Next, S is one variable. Next, after S, I is one variable. M is already covered and we don't have any variable. Next, you have to check whether that is constant variable or dependent variable, right? If it is a independent variable, the space complexity is one word. If it is dependent variable, you have to check the variable is depending on how many variables, right? So see here, don't get confused, I will explain. Here A is what? Array variable. You can check here A is what? A is depending on another variable. Okay. So how we are getting the A value? A of 0, A of 1, A of 2. So this based on the I value, we are getting the array element, right? So here A is depending on one variable. So the size of the array will take n words. The space required by this A variable is n words. Okay. Next, M is not depending on any other variable. M is constant, right? So M takes one word space and S takes one word space and I takes one word space. Okay. Simply you can say what is the A is what? Array. Array nothing but what is the dimension of this array? Array contains what? N values, right? This is the one dimension array. So array contains, for example, 2, 6, 20, 5, 4. Okay. So if array contains, this is array contains one dimension array. This array is one dimensional array. So if it is one dimensional array, nothing but what is the space? To store n values, it requires n words space. Okay. If it is a two-dimensional array, to store all the values, it requires n by n space. Okay. So if you know the dimension, directly you can write n words or n square words, n cube words based on the dimension. If you don't know what is the dimension of the array, if you will get any confusion, then you can check is this array is depending on any other variable. It is depending on how many variables. If it is depending on only one variable, the size required by this variable is n words. The space required by this variable is n words. If it is depending on two variables, then space required by that array variable is n square words. Okay. So P is equal to C plus SP. So C nothing but these all are constant. So 1 plus 1 plus 1 plus SP is equal to N. So that is what 3 plus N. So this is the space required by this algorithm. Next example, sum of two matrices. So algorithm add A, B, N. Here A is the array, B is array, and N is the size. For I equal 0 to N, for J equal 0 to N, C of Ij is equal to A of Ij plus B of Ij. So this is the formula to adding two matrices. Okay. So stop this video and calculate the space complexity of this algorithm and come back to the video and check your answer here. Okay. So now we will calculate what is the space complexity of this algorithm. So what is the first step you have to do? You have to note down all the variables of your algorithm. So what are the variables we are having? First one A, next B, next N, next I, N is already over, next J, next C. Right? Next, you have to check whether that is dependent variable or independent variable. If it is dependent variable, you have to check the variable is depending on how many variables, right? If it is not depending on any other variable, the space required by the variable is one word only. Clear? So now, A is what? A is not a constant. This is array variable. So you have to check. A is depending on how many variables? 2. So what is the space required by this array variable? N square. N into N, that is N square. Right? N into N. Clear? Next, B is what? B is not a constant. B is also array variable. Right? So what is the space required by the B variable? B is depending on how many variables here? 2. So B variable space is n square words. Next N. N is what here? Constant. It is not depending on any other variable, right? So one word only. I takes one word space. J space one word space. And here C. Coming to the C. C is not a constant, right? C is array variable. So you have to check. C is depending on how many variables? I, J, right? So the space required by the C variable is n square. Next you have to sum all the words. So how many n squares we are having? 1, 2, 3. So 3n square. So 1, 2, 3. 3n square plus 3. This is the space required by this algorithm. Clear? I hope you understand this example. Next algorithm, multiplication of two matrices. So you have to note down all the variables of your algorithm to compute the space complexity. So what are the variables we are having? A is one variable, B is one variable, and N is one variable, I, J, C, K. So these are the variables we are having in this algorithm, right? So next you have to check whether that variable is dependent variable or independent variable. So here A is dependent variable. So A is depending on two variables. So the space required by this variable is n square, and B is also n square, and n is independent variable. So space required by this variable is 1, and space required by this variable is 1, and j is 1. C is what? Array variable. So space required by this variable is n square. K is what? Independent variable. So the space required by this variable is 1 only. So next you have to add all the words. So how many n squares we are having? 1, 2, 3. So 3n square plus 1, 2, 3, 4. 3n square plus 4. So this is the total space complexity required by this algorithm. So I am stopping this video. In the next video, I will explain how to calculate space complexity for the recursive algorithm. So if you have any doubts, post your doubts in the comment section. Definitely, I will clear your doubts. Thank you.